hopefully it works. We'll see. We'll see how it goes. Okay, so I wanted to go over what we talked about actually on Tuesday really quick. So on Tuesday, if we recall, we had the recursion lesson. So that was inside of where we code JavaScript, and then the last slide of the day was our recursion slide and recursive Fibonacci, which is not, you know, the most trivial thing we could have assigned, but it's a little bit of fun. Oh, hold up a second. Let me go back and see if I can get to the slides, and they're definitely not doing what I wanted them to do. Let me see if I can show them and then go to the end. Okay, there's something broken on that. That's frustrating. Let's talk about recursive Fibonacci really quick. First of all, was anybody able to solve this just with recursive functions? Or did anybody attempt to do it with recursive functions and feel like they were like moderately successful with that? We got one? Is that it? Really? Okay. So who like attempted and just like it just didn't work for them? Yeah, at least another one or two. Okay. All right. Cool. So valiant efforts. We can show some examples, and if people want, they can send me their examples. And I'll put them up, and we'll see if we can have those serve as sort of like inspiration for other people, which I think is helpful. All right, and then we only had one who was able to complete it. It can be tough. This can be tough. The way I go at this is by thinking about the definition of how you get a Fibonacci number. So I just want to write that up on the board really quick because it's actually kind of helpful to think about it. So if you had a Fibonacci number, so if you had some Fibonacci number, but you don't know what number it's going to be yet. Like it could be the 10th Fibonacci number, or it could be the 100th or the 42nd, or whatever Fibonacci number, right? So we're going to shorthand that and use a variable in order to fill in for which Fibonacci number it is. So Fibonacci number n, okay? So like some number between 1 and infinity, right? What that's going to equal in like formulaic mathematical notation here is Fibonacci of n minus 1, because it's, remember, we had 0, 1, 1, 2, 3, 5, if I can draw, 8, right? So 8 here is our 7th Fibonacci number, right? So it's dependent on the 6th and the 5th. It's dependent on these two right here. Because you have to add 3 and 5 together in order to get 8. So what 8 is it's dependent on the one just before it and the one 2 before it, right? So n and n minus n minus 1 and n minus 2. N is dependent on the number before it and the number 2 numbers before it. So n minus 1 plus fib of, fib, not fin. This isn't a French film. N minus 2. Okay? So this is like, if we want to just think about the problem, this is, we could put it up in like some symbols on a board and maybe help us think about how to write code for it. Connor, you have a question?
Is n minus 1 supposed to be like the index?
Yeah, it's the index. That's exactly right. I should specify that. So Fibonacci at some index is equal to whatever Fibonacci at that index minus 1 is plus whatever the number's index minus 2 is. That's how it's always defined. There's a bunch of different ways that you can like write code to make this work, right? But if we were to break it down just for a second into some code, we might be able to find a couple of patterns that we could use to help us. So the first pattern that we can use is that this pattern here, this holds for all Fibonacci numbers except for two numbers.
0.
For 0 and 1. And which indexes are 0 and 1?
0 and 1.
0 and 1. Yeah, exactly right. So what you can say here is that if your index is 0, you're going to do something different. And if your index is 1, you're going to do something different. Right? But I mean, you know, these have known solutions, whereas all of the other ones depend on these two known solutions. Okay? So if you were to have some code that started off by checking to see, is the number that you're looking for, the Fibonacci number of the index you're looking for, is that index 0 or is it index 1? Because if it is, we have some known solutions to those. So we could have a function here, fib, and I'll actually write it in full JavaScript so that it's accurate. So I'll say function fib, taking some index, so I'll just call it index for now. Some index. All right, it's going to have our body of our function here. Okay, so the known solutions are 0 and 1. So if the index is 0, then the number is 0. All right, so if index equals 0, right? Then we want to get 0 out, so we would return 0. So that's our first condition. And then a second one is the same thing, it's just for 1. It's the same thing, it's just for 1. So we can have another line that just says if index equals 1, then we just want to return 1. Okay? But now, those are the two cases that we know about. They're the two special cases for Fibonacci that we know about. They're the terminators for Fibonacci. They're the things that actually stops the recursive calling of a function to the same function definition. So did anybody watch Matthias's talk? Only one? Okay. One of the things he said in his talk is that recursion gets a bad rap as being complex, but the definition of recursion is that it's a function that calls itself until it doesn't. So it has to do that doesn't part at some point, or else it's just a while loop with a true. It just never ends, right? So we don't want a while loop with a true, right? We don't need one of those. So the last part here is that these are our terminators. They actually stop the function from calling itself over and over again. So we need the part that calls itself, okay? And the part that calls itself is now we need to return whatever the definition of Fibonacci is. And the definition of Fibonacci is right here. It's Fibonacci n minus 1 plus Fibonacci n minus 2. So why don't we just try to write that without this part? Because we can't say fib n equals that. This is the whole definition here. So we just say return. We would say return. It would just be return, return.
Fib dot index.
Yeah, fib.
Fib num dot index.
Yeah, index minus 1 plus fib at index minus 2. That's it. 3 lines. I wonder if that'll run. I wonder if that'll run. Let's see. So let me open up iTerm really quick, and then I'll launch myself This takes a second. As soon as this boots up, let me open up, let me cd into code live, which is where I had the code from last class. And now I'll go ahead and just open up VS Code inside of here. All right, here it goes. And I wonder if this will work. So I have some JavaScript here. I don't know why it's not like, there it is. So I named mine a little differently. Mine is called fibof instead of what it was. But let's see if this works inside of Node Console really quick. So if I open up a Node Console and I put this code in here, so I can give myself a little bit of space, I'll just paste it in. So I have fibof right now. If I give it the 10th Fibonacci number, does anybody know what the 10th one is off the top of their head? 34. It's 34, yeah. Oh, wait. Did I give it? I think I have the wrong. If it's the 9th one, yeah, I have my indexes screwed up. So the 10th starting at 0 is 34, right? So that means that this function gives me back, so the first one, or I should say the 0th Fibonacci number is 0, and 1 is 1. So that would mean 2 is 1. And that would mean the third index is what? 2. 2, yeah. And that means that the fourth one should be, should be 3, right? And so the progression is working as expected. I always remember the 2, 3, 5, 8. If I get those, I'm like, okay, I'm good. I can stop here. I feel confident. Yeah, Ron.
Just a clarification. When I did the lab, it said using recursion running a program that would print out the sequence,
yep,
as opposed to just calculating.
Yeah. So this is part 1 of a 2-part thing. So take a look at my screen, and you'll see a second part.
Are you on the second part now?
I'm gonna talk about the second part right now. So this is a two-part solution. The first is I have a Fibonacci definition here that is just the simplest bit of Fibonacci code that I could put into JavaScript that parses, right? So if it's 0, return 0. If it's 1, return 1. Otherwise, return a recursive call with fib minus 2 and fib minus 1. Add it together. That's as simple as I could think of it. If anybody has a simpler one, I would be super impressed, and I would love to read it.
I ended up starting out with the initial sequence 0 and 1 as an array.
Yep.
And then just sort of pop stuff on the.
Yeah, that's one way. That's one way to do it. Remember, this is not a prescribed solution. I'm not saying if you've got something different than this, you're wrong. I'm saying that this is the simplest solution that I could think of, and my brain is different than yours. So you may end up with a better solution.
All I'm saying is I thought we were supposed to print it out, so that's why
Yeah.
I'm saving it as opposed to just.
Yeah. So if you look at Fibonacci numbers, taking numbers here, okay, this goes ahead and so this takes an array of numbers, and if it starts off as an empty array, it says if number's length is less than the max fib num. We get that from the process argv. So if I passed in 10, right, you would calculate up to the 10th Fibonacci number. Or actually, it goes up to number 9, which is the 10th, because of the index weirdness around zeros. And it says, hey, all right, so we've been called. We have an empty array. So now we're going to push onto numbers. We're going to push onto numbers the call of fibof with numbers.length. So when numbers comes in as an empty array, it has a length of 0, which is convenient, because it means get me the 0th Fibonacci number. And then it says numbers equals Fibonacci taking numbers again. So this one also is calling itself. It's furthermore a recursive function. And so numbers here is waiting for this call to Fibonacci numbers. And then this one is, again, waiting for this call to Fibonacci numbers, and waiting for this call to Fibonacci numbers, and so on and so on and so on, until it gets to finally the last call, and then it pops that call, which pops the prior call, all the way up the stack until we finally get this numbers assigned. And then we're done. And we get back numbers. So let's see if it works. So theoretically, if I call this from node, let me exit node here really quick, and I say node recfib. I did run this, so hopefully it works. Oh, you know what? It gives me an empty array first time because I didn't put the 10th one in. All right, there we go. Now, is this a super efficient solution? Probably not. This is actually a pretty inefficient solution to this problem. Why is it inefficient? You might tell me.
Could you combine?
No, Emily and then Ira. Yeah.
Because like you're like kind of like artificially making an array versus like.
Yeah. I mean, I don't think that's the worst description. The problem is that I timed this. I profiled it and I checked to see how many stack frames do I create to calculate 10 numbers. It turns out it's 284.
It's sort of repeating some steps.
Yeah, it's repeating some steps. Exactly right. Where is it repeating most of the steps? Is it repeating most of the steps in the lower Fibonacci function or the upper fibof function?
Lower.
Who wants to say lower?
Well, it's a question. Who said yeah, lower?
Yeah, where's most of the processing time coming from? Lower function or the upper function? Lower? I'm getting a lot of lowers. Does anybody think it's the upper one? Ira thinks it's the upper one. Okay. So let's, instead of guessing, let's try to figure it out. So if we had a couple of variables here, let's say let fib of count equals 0, and then we'll create another variable here called let, I'll say array count equals 0. Now let's go ahead and do some stuff. So right at the top of the function, let's just take whatever fib of count is here. I need to have this complete the right thing. And I'll say plus equals 1. This just means make fib of count equal to it, whatever it is now, plus 1. Right? So it's assigning itself to itself plus 1. And now we're going to do the same thing down here in the Fibonacci recursive call. So we'll say array count plus equals 1 as well. So both of these on each call, they add 1. So now we need to actually log them. So I'll do console.log. I'm going to do a little trick here that I haven't taught you all yet for nice logging of a thing. And I'll explain what it does in a minute. So I'll say fib of count. And now I'll do the same thing for array count, like this. And I'll show you why this is nice in a moment. So I'm going to go ahead and run this. Let's do the same call with 10. I think it was 284. I might have gotten it wrong by like maybe 10 or something like that. Let's see what it is. Oh, it's 276. I was wrong. It's 287. Okay, so fib of count does it 276 times, and array count only does it 11 times. Ira was correct. Well done, Ira. Now, why is that the case? Can anybody tell me why? Missy, and then Ron. Sorry.
You're doing 2 different recursive calls in the top ones.
Exactly right. Yeah. It's recursing twice. And what is each one of these calls doing?
Calling again.
Twice. Yeah. So we call it the first time. I'm going to erase this now, if that's cool with everybody. So this is a pretty inefficient way of doing this because we are not doing one recursive call for one answer. We're doing many recursive calls for one answer. And that is not super great. because we start off here at the beginning, and then that calls off to 2 recursive calls, right, to get our first number, and then each one of those goes, okay, cool, yeah, I'll make 2 more calls, 2 recursive calls, and then this one makes 2 more recursive calls, and then this one makes 2 recursive calls, and then this one makes 2 recursive calls, and this one, and this one. And we have to wait, so this would be 0, 1, 2, 3. This would be the 3rd number here, 2nd number, 1st and 0th number, right? Through this downwardly projecting tree of recursive calls. And we need to wait for all of these here to finish before we can just get the 3rd number. That's not super awesome. That's pretty inefficient. So if anybody wants to try this again before next week and feels like they can improve this while still using a recursive call, I know that it can be done, but I would love you to think about it. Okay? So while my solution might look really pretty, it might not be the best solution, right? There might be better ones out there. Even though this one kind of maps really cleanly to like the Wikipedia explanation of what a Fibonacci definition would be in math. Okay? Any other questions about that before we move on to debugging? If not, that's cool too. I just wanted to see if there were. And did I miss any hands? Okay. Cool. And by the way, both of yours don't have to be recursive. I just happened to make mine recursive because I wanted to feel fancy. But you could have a while loop as your like accumulator, and then just have a recursive call in your Fibonacci number. We just want you to use recursion somewhere. We're not saying in this challenge you must use only recursion and you can't use any for loops or any while loops or anything like that. That's not what we're trying to say. So if that came across that way, I'm sorry, that wasn't by intention. Okay, cool. All right. Anybody else have any more questions about this before we move on? All right, sweet. Cool, so let's talk about debugging. I'm gonna close this up. You know what, I'm actually just gonna switch it over to Chrome. All right, sweet. So let's talk about debugging. When you're doing recursive stuff, a lot of the time you're gonna have to debug your code. Unfortunately, that is part of the game. Oh no. This is like not what we want. So I'm gonna have to do something a little wonky in order to make this work. I'm gonna have to just show the slides on the screen because it looks like there's a bug in our slide code. Just make sure that it's not just that set of slides here. And it's yeah. All right, so let me just notify Alex that there's a weird bug and see if he can push a fix while I'm teaching, and then we'll get back to regular business.
That's actually appropriate for that to happen during this lesson, right?
Yeah, maybe we should debug it, right? Yeah, exactly right. Let me just hit them up really fast. So in here, we want to go into JavaScript.
It's your 802 Slack channel.
Oh, that's the one I run. I'll show you that in a minute. Okay, let me just send this over. Yeah, I run the Burlington Developers Slack channel.
Gotcha.
So, so let me just say, let me see if I can hit up Alex here. Let's see here. Can you fix this while I am teaching? There's a bug in JS slides not displaying while.
What's the workspace for this class on Slack? You really know if students of ECF. Thank you. BTVCA.
It bugs me that the icon for our Slack channel is SO.
It is, yeah, it kind of bothers me too. We'll try to get like an icon or something that seems cooler.
That'd be cool.
We'll get some like famous internet cat or something. That'll be so much better. All right, so Alex should respond to that fairly quickly. He's usually good about that kind of stuff. In the meantime, okay, so I can't, let me just see if I'm in, okay, I'm in general, cool. Sorry, I get like admin messages and stuff that I can't necessarily share. But this is Burlington Developers. If you want to join, I'm the owner of this channel. And if you're interested, you can go, I'll just show you really quick in here in sign up. It's a community for local developers. It's not just for Burlington. It's really for like northern Vermont. And there's a self-sign up. This is the self-sign up. You're welcome to join in if you'd like and register yourself. We have, you know, almost 750 people or so, close. We'll be there soon. And there are a number of opportunities on there for work and that kind of thing. I'm sorry, I closed that. I meant to leave it open. What I'll do is I'll paste this into the Slack for everybody. That would be good. And so let me come back up to here. And I will say, you can join BTV Dev here. There you go. Cool. Alex got back. I don't know what's going on. All right, great. So let's get back to business. Let's do, I can't show full slides right now. I'll wait for Alex to get back to me. So let's come into debugging really quick. Debugging. Cool. So debugging. The first step in debugging is really obvious, but it's very quickly missed, which is that when you're debugging a program and something goes wrong, most of the time you're going to get an error of some kind with a stack trace afterwards, right? We experienced that just like 2 classes ago, and I can make that happen right now by simply coming into VS Code, and I could change this to array counts instead of array count, and then I will cause an error as soon as I run this code. So if I run it like this, oh look, I have an error, it's big and scary and stressful. And most of the time people skip reading this error because they tense up and they feel like, oh, I did something wrong, I'm stupid, I'm a bad programmer. I have to Google for the answer because I'm so dumb that I couldn't figure it out myself. Like, this is a feeling that I've felt many times, so I know what it feels like. And the real solution here is to actually just like hold on a second and compose yourself. Like, it's just an error, it's okay. You can't really break your computer very easily unless you like drop it on the floor or drop it in the bathtub or something. Like, that will break it for sure. But breaking it with an error from JavaScript is like very hard to do. You'd be hard pressed to make that happen. So what you need to do is realize that the computer has a hard time communicating. All right, it's kind of like a very young toddler or child or something, and it's trying to tell you something here. Okay, it's trying to tell you something, and it just doesn't have the words. It just doesn't have the words. It's really frustrating. So you have to read the error, and that includes the stack traces. Let me see. I might be able to do something really quick here to make this a little easier to read. Boom, boom, boom. Let me see if I make this smaller. Yes, okay. I can fit almost an entire slide on the screen. That's better than it was. So you got to read the error, and that includes the stack traces. And it's totally cool if you're like 98% of the stack trace is not what I want to see, because everybody feels the same way. You just got to find the spots that do apply to your code, and I'll teach you how to do that again. You got to read your code. That's important. A lot of the times we write code really fast, and sometimes we make little errors and they're kind of hard to see. This is the place where sometimes linters can really come in handy. I mentioned a few times linters can be very difficult to use when you're programming because they break your flow of concentration. And if you turn them off, sometimes you program better. But if you have an error and you're not sure why, sometimes turning that linter back on can be a really good indicator of why. So turn on your linter at that point. See if maybe you have a variable that is named but not used. And that might be an indicator that like you're referencing a variable name that is a misspelling or something like that. In my case, I had a stack trace. It told me what the variable was it was trying to reference. And it even told me where it was in the code. And I'll review that in just a moment. The other is that if you've done these steps and you still can't find it, can't find your problem, start putting print statements into your code. This is a quick way to start logging out variables while your code runs. And they don't have to be only variables. You can also put in console.log statements that do like, I'm inside the loop here. I'm inside this function. Those can be really helpful because when your program runs, what you need to do is get yourself a ground truth where you know for a fact that this part of your code runs the way you expect it to, even if that's the very first line of code in your program, but I'll teach you some tricks to make that a little faster. So once you have a stake in the ground and you can say, okay, I know that the world is this way right here in my code, then you can start building on top of that foundational cornerstone. But if you don't do that, then you're always unsure if your code is the way you wanted it to be or the way that it is, which is different than what you expected. And almost every bug is an assumption that you've made that is incorrect. You think the world is one way, the world is actually another way. That's 95% of bugs. All right, so print statements help you to put some stakes in the ground to figure out where you are. The other is that if you're at this point and you still can't figure it out, and you're like, I don't know what's wrong with me, my brain isn't working, if you haven't had enough caffeine today, or haven't eaten in the last 2 hours, go ahead and grab one of these little guys. And if you don't have one of these, then maybe you have something else in your house, like you have a picture of a pet or something, and you can take the picture of the pet and put it in front of you, and then talk to it as though you are explaining every line of your code to another living thing. And so you're explaining it in a very slow, pedantic way, covering every single piece and not leaving anything out. That's the important part. If you skim through your rubber ducking session, you're likely to miss your bug. But if you walk through it very slowly and deliberately and calmly, you will probably find your bug before you get to the end, which is very weird, but it works almost all the time. And then the last tool is that you can use an interactive debugger, okay? But I don't reach for these first. And that's because this is the most heavyweight tool you have. It would be like taking out your chainsaw to like, trim your hedges or something. It just doesn't make any sense. Like it's the biggest, most powerful tool you have as a developer to debug code. Maybe except for tests, which we'll get to in a little bit. But if you can solve the problem before you get to this point, you've actually saved yourself a lot of time. Because you're probably going to be stepping through your program, looking at every little line, going into libraries by accident, getting sidetracked, confusing yourself on how your debugger works. These are all things that I've experienced, and I'm trying to help prevent you from having to experience them too. Okay. So that is the rundown of what we're going to be doing here. So debugging is fixing your code that you thought was working, but it isn't working. Or as I like to say, you believe the world is one way at a particular point in your code, when in fact the world is another way. It's like one of those moments from Inception where like they're inside the dream that's inside the dream. And they're like, oh no, which dream are we inside of? It's that kind of thing.
It's like being in the loop inside of the loop.
Yeah, exactly. Yeah, inner loops, exactly right. So The point is like, if you have an assumption on how the world is and it turns out to be wrong, then you build on top of that assumption. You now have like a fracture in your logic. And keeping bugs out of code is all about having the logic of your program hold. And if it starts to have like tears in it or holes in it that are hard to find, a bug will sneak in there, I guarantee it. Guarantee it. And the other thing about debugging is a little bit like solving a puzzle, except for you created the puzzle too. So you got to make the puzzle in your code, and now you get to solve it. The other thing about debugging, which should be stating the obvious here, it can be super frustrating. Like I've debugged problems for days, like not different problems, the same problem for days on end, trying to find the problem, the actual problem, right? Not what happens, but like what's the cause of this bug. And I would think that I would find it, and I would fix it, only to find out that the bug didn't stop, and it was like still happening, right? So anyway, debugging can be incredibly frustrating. However, you just have to have the persistence to push through it and get to the other side. Debugging your own code can be incredibly frustrating. Debugging somebody else's code is even more frustrating because it's sort of like reading James Joyce. Like, it's painful and you didn't write it, so you have no idea what this means, and you're trying to like untie it one little bit at a time. Okay? So you'll be tempted to pull an Alexander the Great and cut the knot in half, but you just can't cut this knot in half. It doesn't work that way. So generally, bugs are going to come up, errors and failures. All right. The failure here is that the program runs to its end, its natural conclusion. All right, but the solution is wrong. The solution is wrong. You didn't account for every condition that could happen, or maybe there's some kind of weird situation where part of your program completes before some other part, and that actually gives you a wrong answer some of the time and a right answer some of the time. Those can be really difficult bugs to actually sort out. And the other type of debugging or failure here is that you actually get an error in your program. So this is nice. Actually, these are great because now you know where the program stopped, and you know that if you run the program again, the error is going to happen again, which is awesome because it means that you can run your program over and over again. I'll wait for the siren to stop. I think they're going the other way. So I much prefer errors over failures or bugs because you have to find the failure or the bug. Whereas with an error, it's like this thing won't work, right? It's like your engine catches fire when you turn it on. You can't. It's not going to keep. It's not going to keep running. All right. So when you're debugging a failure, these can be difficult. And keep in mind that this is very much art and not science, and people get better at this over time. You want to make a mental model of your program, and sometimes that means adding comments throughout your program to talk about what the different parts do so that you can better think about it as you're trying to debug it. You want to think about some potential reasons why this bug could happen. And sometimes it helps to like close your computer screen and write some stuff down on paper before you look at your code again. Like, what could happen from what's inside this program that could cause this problem? And then you want to start making observations to confirm or reject those hypotheses. And these observations could be console.log statements. So when I said like putting a stake in the ground, I mean that the console.log serves as like a way for you to say, I know that the world works up to this point. Okay? And then you want to focus on the anomalies or the things that are not behaving correctly, like ignore everything else. And then here's a really important part that a lot of people don't do. They change a lot of things in their code, and then they check to see if they fix the problem. you can't tell if you fixed the problem if you change more than one thing at a time. You can't tell what changed it, what fixed it. Because if you change two things, it's now in one of those two things, or in how those two things work together. So that's three things, which is, now to add a fourth one in there, and suddenly we're talking about an explosion of different possibilities. So it's really important for you to change one thing in your program and then run your program again and see if that one thing fixed the problem. And if it didn't, change the next smallest thing that you can. And just remember to stay calm through this process because it gets really frustrating. Now, you can start at the beginning of your program and change one thing at a time from line 1 to line 2 to line 3 to line 4, all the way down to, let's say, line 100 if you have 100 lines of code. But I wouldn't do that. Instead, what I would do is start console.logging early in the program and making sure that it's working correctly at the very beginning. And then I would put some console.logs in the very middle of the program and make sure that, okay, is it correct in the middle? Does it get to the middle and give me what I think is supposed to happen? If you're able to cut out half of your program and say my problem does not exist in this half, you've just cut your problem space in half versus going by line 1 to line 2 to line 3 to line 4 to line 5 and so on. So if you can bisect the problem, cut it in half, you can solve these very pernicious problems with many fewer steps. So that means a lot less time actually spent trying to figure this stuff out. Okay. Remember to relax. So this is how you would debug with print statements. Okay. If you had some factorial program, you could log some stuff right up front. So the input here is X. Log what's coming in. Log inside of your conditionals. Log inside of your else's. Okay? And then these actually return from the conditional. So in this case, you've now logged at every point in this little function. If it had more below here, below the conditional, then you could also have more log statements inside of there. Don't worry about adding console.logs. You can always take them out later. It's not going to break anything. Console.logging doesn't have a side effect on your program. By side effect, I mean that when you log out information to your console, you're not going to change the way your program runs. It's very hard to do that. And so be liberal with where you put them. Don't be afraid to add them to your program. And then you can always go find and replace later and pull all these out. Okay. So this is what this would look like if we ran this factorial with those log statements. And by the fact of being able to see how your program changes over time, how the data in your program changes over time, you will get an intuitive sense of when things are going right and when things go sideways. And it's all about being able to use your spider senses to figure out when they go sideways. Okay? Can anybody see the bug in this? We're getting out 0, right? Let's look at the code. Factorial comes in. Factorial 3, right? So 3. Is it less than 1? No. Come down here. Factorial 3 times the factorial of 3 minus 1, which is 2. 2 comes in. Is 2 less than 1? No. Right? So it says turn x times factorial of 2 minus 1. Comes back around. 1 is less than 1. No. Factorial of 1 minus 1 is 0. Finally returns 0. Oh, what's a number times 0?
0.
So what's the bug?
Less than or equal to 1?
Yeah. Yeah. It's a simple signing problem. It goes one number too far, and that will zero out your entire calculation, even though everything else is going right. And these are the kinds of bugs that will bite you, and you won't think about them until your program goes wrong, and this is why it's important to be able to check this stuff out. All right? Another one I see a lot of here with these kinds of conditional statements is that people don't do a equality comparison. They make an assignment inside of your conditional. They'll do, if this was doing like an x equals 1, they would say, I've seen this bug happen so many times, x equals 1, 1 equals sign. And unfortunately what that means now is that this conditional will always return true because x equals 1 returns the assignment. And then you will always have this run, and you'll never reach this branch condition, and your factorial will not work as intended. So I just know about where these things happen because I've experienced them so often, but you will get familiar with this too as you write more and more programs. Okay? But you notice how by just walking through this step by step and talking about it, we were able to find the bug just by saying the last cycle, versus if we had just looked at it and thought about how does the code change. Well, by thinking about it, you can skip a step, but by speaking it out loud, it's really hard to skip a step if you're speaking it to somebody else and trying to keep them informed of your thought process. But in your mind, you can skip over things because you're like, oh, I know the answer to that. I don't need to explain it to myself. My mind already knows because it knows it right now as I'm speaking. But when you're explaining to somebody else, that changes. Okay? One thing here we haven't gotten to yet is that you can use unit tests. And does anybody know, like, who here has ever used a unit test before? A few people, about a third. Okay, cool. So a unit test is a program that runs another program and determines if the program that it runs returns the result it expects. So you're verifying the result. For example, if you were to test the factorial program that I had up here earlier before, I know that the first factorial is 0 and the second one is 1. And I also know that the 10th one is 34. I could put in some factorial numbers into my factorial function and make sure that I get out what I expect. And if I don't get out what I expect, then I know that the code that I have written is not correct. And a lot of people skip unit tests because they feel like extra work. Oftentimes, like, I'll write more unit test code than I will write code that actually does what I want. But that is of a benefit because what it does is ensures that when that code changes in the future, it still will adhere to the contract that I set up between the code and the test. And the contract is really the intention of your program, right? The contract is implicit when you just write the code, but it's explicit and enforced when you write the code in the test. And we'll talk about this a lot more in like a class or two, all right? I'm not going to go into depth on it right now. But tests are one of the best ways to debug things because you can just add more tests and try those side cases, those edge cases rather, that you didn't anticipate and that are causing a bug. Yeah, Zach.
In my past experience, like if you're iteratively working on some software, people come up with bugs and they'll add those test cases in, so it's something that you're always going back to check every time you're doing a release, making sure that bug hasn't popped back up by doing something else, breaking something else, or whatever.
Yeah, and you don't want to do that by hand.
Yeah.
You don't want to have like a spreadsheet of bugs and have to go through and cause all those bugs to happen. That's like the worst case scenario.
The company I worked for was all hand debugging.
Yeah,
And
a lot of
testing
companies
and
are,
stuff.
and that's why I'm actually bringing that up. This is not a joke.
Yeah.
A lot of companies keep their bug databases in spreadsheets. I've known several just in my short experience.
Jira for ours.
And the problem with that is that now you need to keep those bugs in your head as you are writing your program. You want your test cases to be written in code so that you can run them using a computer. Because you don't want to be manually going through your program and testing all these edge cases. That's the worst case scenario. It's actually one up from the worst case scenario. The worst case scenario is not actually testing for your bugs and just assuming that when you fix it, it'll always fix the problem. That's actually the worst, because you will have bugs. You always have bugs. You just sometimes know about them, and sometimes you don't. Okay? All right. So let's go forward a little bit. We talked about rubber duck debugging. The rubber duck is your friend. And if you practice this, meaning that you go through and actually explain every line to your rubber duck. This is my plastic duck. This isn't actually rubber. I can't squeak this duck. And it might not float. I don't know. This is a 3D printed duck that one of our TAs made for us in the past, which was very nice. But if you just, it's all about the process. It's like you're kind of going through a ritual, and you don't want to deviate from that ritual. You want to go through every line. And it's better if you have somebody who's a real human being sitting next to you, because they force you to actually explain every line, rather than you forcing yourself to explain every line. So I do recommend that instead of having a toy duck, you have a real person that you can talk to and you feel comfortable with. That's the best case scenario. But if you don't, and you don't have like a very friendly dog who looks up at you or something when you talk to them, then our rubber duck is like a great stand-in. So you can, like I said, your rubber duck can be a metaphorical rubber duck. It could be another toy that you have at home or something. Whatever works for you, but try it. It will really work. This is not a joke. Like, programmers have been doing this for decades. Talk about this. Okay, so I'm going to go back to that error in a second, but here's how you read the error. You want to dissect the error report. So when you get the error from your program running, I'm not talking about an error that a user submits via email or something to you saying like, I tried to type my name into the form, and when I did so, and I used only 4 characters for my password, you rejected my password. That's a bug, right? Like, that's a nice report from your user, but it's not an error report. I'm talking about a computer's error stack trace, okay? You want to dissect this. So you want to know where in your code is this error coming from. That's number one. And it's not always where you think it is, all right? I'll give you an example in a minute. What's the name of the error message that's getting raised, okay? And why is this error happening at that point in your code? All right, I don't mean now in time, I mean now in space throughout the code base. Sometimes, however, it could mean now in time if you have what's known as an intermittent error, an error that doesn't happen every time. Those can be very challenging. I'll give you a great example. A lot of people have errors that only pop up in March, April, or October, November. Does anybody know why? Think about it.
Taxes or something?
It does have to do with a certain time of year.
The days of the month. Maybe?
Days of the month is kind of related, but not exactly right. What changes during the fall and the spring?
Daily times.
Yeah, time. Yeah, daily savings time changes. And so what happens sometimes is that daylight saving times applies in the United States, but it doesn't necessarily apply to every country in the world. And if you haven't accounted for daylight savings time correctly, and you don't use what's known as like GMT, Greenwich Mean Time, or UTC, Universal Coordinated Time, you're going to hate your life. because dealing with time zones is the bane of all existence. It's the worst thing ever. They don't make any sense. They're political boundaries or regional boundaries. They aren't even necessarily all within the same country. Sometimes you'll go north and you'll think that you're in the same time zone as the country to the south, and that's not necessarily the case. Not all time zones progress as you go further to the east, and not all of them regress as you go to the west. It's very bizarre. So just keep in mind that like time zones are very hard, and prepare yourself if you ever have to deal with that. My point is that sometimes you get an intermittent bug, such as, is there a reason why this error is happening today and it didn't happen yesterday? I've had this happen to me multiple times, particularly around like the time of events or something like that. Or I've been dealing with devices that have been set up by somebody who's not that technically experienced, and they set the time zone to a local time zone instead of to a universal coordinated time zone, and now you have to like convert time just for that specific device. I used to have to work a lot with like remote devices talking to central servers and stuff, so that was like a very common bug for me, and I would know right away what the problem was, but only because I had struggled with it for so long. The other is, what's the context of the error? So by context, we mean like, what is the details surrounding the error, okay? And the last is that, what's the code expecting? And what did it get instead? Again, this is the world expecting one set of facts, and then they get a different set instead? If you get several errors, which happens sometimes, which one is the root cause error? What's the error that actually causes the problem? Because sometimes an error will cause a cascade of other errors to get raised all at once. And what you need to find is what's the like patient zero, right? What's the one that originated the actual problem? And then work from there, okay? Okay. Let's see if I can show you the stack trace here. So if we come over to our stack trace, and I'll make this a little bigger. There we go. So array counts is not defined. We know what this actual problem is that array counts is spelled incorrectly. So our context is that we have some part of our code, this line here, that's expecting to increment array counts, but in fact the variable is called array count, and the problem is not with the variable named array count, it's with this variable here. All right? And if we look at this stack trace, we see that the most recent line of code in our program's execution is the first line, which means it's the highest one up from your cursor, which can be hard to read sometimes because this is actually a very short stack trace. This is only about a dozen frames, stack frames, but I've had stack traces that go on for a long time, and you need to actually scroll up several like terminal console screens in order to find the original problem. So if you're reading down here, you're almost never going to find the error correctly. It's almost always at the other side, and you want to read from the top down to see this is the oldest stack frame, the one that started everything, and this is the one that's nearest to your line of code. And you can actually read your code if you want. So you can see that this is a path to where the code lives on the computer, and these are paths to code that's inside of Node's JavaScript engine. So my error is not inside of JavaScript engine, it lives inside of my personal code base. All right? Okay. Oh, one more thing that I didn't mention. If you look at the full path, you can note that the last part is the file name, and then there's these two colons, :14, :3. So what's the :14? Does anybody know?
It's the line.
Yeah, it's a line number. And what's the :3?
It's the word or something.
It's the character column. Yeah, it's the character column. So in my code, this is the third character column, and that's where the error actually originates from. Sometimes that can be useful. If you have a line of code that does more than one thing, and you're not sure if your problem is at the beginning of the line, or in the middle of the line, or at the end of the line, you can actually count forward by however many characters are in that line and find where the problem comes up.
Character columns.
Yeah, so if you look at Visual Studio Code here, you note that this A is on line 14, column 3.
Okay, gotcha.
That's where that is. So you can actually move your cursor across, and you notice how the column changes as I move from left to right, but the line does not.
Gotcha.
So that's actually how you can know what column you're in without having to do some kind of weird like selecting and counting or stuff like
And
that.
it's literally like columns.
Exactly. It's literally like a grid. It's literally like a grid.
Okay.
Yeah. Okay. Cool. Let's look at the last slide here. Okay. We've talked about what the error message is. I'm not going to belabor this point too much further, but if you read the entire error message, not just the first name of it, you can oftentimes reveal more information about what your real problem is. For example, undefined is not a function is a really common error in JavaScript. And generally that's going to get caused because some part of your program assigns a variable to undefined. And then you think that that variable undefined is actually like a method on an object or a function that you can call, but it's not. It's undefined. And so you can't call undefined, and so undefined is not a function, and it doesn't work. So an example would be assigning something to a variable and using that as a callback. You're going to get undefined is not a function. Or if you try to call a property on an object and you misspelled the name of the property, and that property would normally point to a function as its value, you're going to get undefined as it's not a function. These can be tricky because the problem is not where you called it. The problem is where you assigned the variable, which may be somewhere else in your code. All right? So that's a very common one in JavaScript, and it's one that you need to be aware of. All right? Unfortunately, JavaScript has many ways to assign nothingness, and undefined is the most common one. Okay. All right. So we've talked about your code expecting one thing and getting something else. I'm actually going to skip that. Which of the errors is the root cause? So if you have several errors that all get caused by the same one, by the same source, I should say, which is the originating source error that causes the follow-on errors. And if you can't identify that source error, using console log statements will help, because your last console log statement will be just before the code that causes the error, most likely. Okay, so it helps you narrow down where in your code that exists. And the last thing that can be really helpful when you're dealing with the browser, which we're going to be going on to next week, is that you can do in-browser debugging. So in-browser debugging, in like Chrome, Firefox, Safari, whatever, you can actually query for the status of JavaScript variables in your console, or you can inspect the values of things inside the DOM and CSS using your browser's inspector tools. And I'll show you what some of those look like in just a minute. Again, this is essentially using a heavyweight debugger. If you have to drop down to your browser's developer tools, you're bringing out a heavyweight tool to solve a problem. You should try to use these lighter weight tools of logging, reasoning, printing things out before you go and dive into your browser's developer tools, because you're going to get into the weeds here. You're going to think something is a certain way. It's going to turn out to be different. You're going to try to follow it. It's going to be a dead end. You can burn a lot of time in your browser's developer tools and in your Visual Studio Code debugger, whereas you might have been able to solve that problem without them if you had used some of these steps that we just talked about first. So going through, the quick repairs and then go into the heavy-duty repair tools afterwards. And there's a good talk on using the dev tools here at this YouTube link. I'm not going to play that during this class, but if you want to watch that over the break, awesome idea. Okay. The last one I've mentioned a couple times, which is that well, they both do, actually. I should back up. Both Chrome and Visual Studio Code have interactive, what are known as stepping debuggers. Debuggers that step forward one line at a time and allows you to inspect various values. So most people don't know that Chrome and Firefox have stepping debuggers, but they do inside of them. They're fairly new. I think they were added like 18 months ago. But they both have a debugging protocol. And you can tie into that debugging protocol with Visual Studio Code's debugger as well. So if you prefer to use Visual Studio Code, you can run your Chrome code, run your JavaScript code in Chrome. And then when Chrome reaches a breakpoint, like I showed last week, it will actually pump you back into Visual Studio Code in which you can inspect variables and that sort of thing. So it can be quite powerful combination of tools, but there's a lot of overhead in learning how to use them that you have to invest. So if you've never used a stepping debugger like in Visual Studio Code like I did last week, and if you've never used Chrome's developer tools, prepare to engross yourself for at least an hour figuring that stuff out before you're going to be like productive in solving your problem. It's going to be like, oh, how do I use this? Where is this tool panel? How do I set a breakpoint? How do I clear a breakpoint I don't need anymore? How do I move forward one line? How do I move forward by one function? These are things that you're going to have to figure out, and if you've never done it before, it's just going to take some time. So don't be afraid of it. It's not like intimidating, but it might just take you a little bit longer than 5 minutes to figure it all out. Yeah, Ron?
Yeah, one other comment about that, like, I've used interactive debuggers for like back-end web development, but not through JavaScript. And because it's non-visual, your debugger can take up your whole screen, but usually like when you're doing it in a browser, like there's a web form or something like that, that little thing appears on the bottom, so there's like very limited room to work with.
Yeah, you do have to kind of set up your tools, yeah.
Yeah.
You can get in a situation where it can be difficult to figure out if you've solved the problem because you're constrained by your window or something like that. Yeah. If you have an external monitor, if you have one, and you can use that, that can help. But again, if you've gotten to this point, it's because you have been working through your problem and you're still not sure what's causing the bug or the error, right? Okay. Maybe we will watch this interactive debugger really quick. This is actually fairly short. Let me show that. Bring this up. Okay, so I think this might be muted. Oh, it is. Okay, let's come back to that another time. This is not going to work for this purpose. What I'll do is I will play this video once I have the speakers set up so that everybody can watch just that video without having my microphone interfere with this, because I think that might be what's going on here. Okay, so I'll do that after the break. Over the weekend, if you want to, we have these debugging challenges from Visual Studio. It's not from Visual Studio, from Free Code Camp. And so there are about a dozen of them that go through various kind of error cases that you're likely to experience on your coding journey. We don't need to do these right now, but I would recommend doing them. Okay. Free Code Camp is free to use. It's free to sign up. And I highly recommend going through these challenges and actually seeing what these feel like to solve. All right? Because you're going to experience pretty much every one of these bugs in your career as a developer, and probably sooner than later. All right. So with that, what I'm going to do is I'm going to take a break a little early tonight, so it's 7:44 instead of 8, because we want to go over our project for the evening as well. So I don't want to go all the way to like 8:15 and then lose a little bit of time. So why don't we break now, and we'll come back at 8 o'clock, and we'll talk about the next lesson, which is Git and GitHub. And once we're done with that, we'll finish up the evening by introducing you to the challenge for the weekend, which is going to be a command line tic-tac-toe game, which should be fun. Okay? And you can take this pretty far, but we'll introduce it in more in depth towards the end of class tonight. So Git and GitHub when we get back, 15 minutes, and we'll see you all then. All right? Cool.